Well, now let's take a look here at example number 2. This is actually an example that we saw in the last section, but we were unable to answer at the time. Let's see what it says. The scores of all students taking the Math 165 final have a mean of 106 points, standard deviation of 12. Now a stem and leaf plot of the data shows that there's a skewed left distribution here. So again, can I use empirical rule? No. And if this is a skewed left distribution, then I know that a lot of the data clumps together over here at the right but tails off on the left. And so again, I know that my average is going to get pulled down into the tail, whereas my median is going to pretty much stay fast. So do I expect the mean score to be smaller, greater, or about the same as the median? Well, again, we should be able to see that we expect the mean to be less than the median. Again, those small values in the distribution that cause the skew are going to be pulling down that value of the mean. All right, well, let's take a look at some of the Chebyshev style questions here. At least what percentage of students score between 88 and 124 points? Okay, this is actually extremely similar to what we saw at the end of the last video, when we had at least what percentage of faculty earn between this much and this much money. And we kind of highlighted in that last video, we had this 3-step process. I'm going to ask you to go ahead and try to see if you can complete that 3-step process on your own. So go ahead and see if you can pause the video and work through this question, get at least to an answer. And then when you unpause, you'll see me work through the solution. Okay, well, hopefully you actually did attempt to try to do that question on your own. And if you did, you should have gotten some results that look like this. We know that there's an average here of 106 points. And we know that we're going to be making jumps of 12 in either direction. If I jump up by 12 once, I know that I'm going to end at something like 118. If I jump up by 12 again, I'm going to end at 130. And so I know that my value of 124 is somewhere in here. That's where I really want to stop. Now, I can make jumps down because I got to get down to 88. And I think I'm going to have to make 2 jumps in this direction to find where 88 would be. So notice again, if I go down 12, I'm going to be at something like a 94. And if I go down 12 again, I'll be at something like a 82. So of course, that means that the number 88 is, somewhere in here. So notice I haven't even drawn my skew left distribution in here. That's not super important. I can kind of see everything that I need just by drawing out my little number line. But again, remember that the first thing I'm going to need to do is find z. I need to figure out how many jumps does it take to get from the center to 124 and from the center to 188. And remember, to do that, we needed to ultimately find the distance between our center and our edges. So we calculate z is equal to 124 minus my 106 should give me that gap. Now quickly, I might be able to tell off the top of my head, this is going to be a total of 18. Now I can see that actually if I go down, I'm also going to get a distance of 18. Remember, that's good. Those should always be the same value with Chebyshev's theorem. So once I have this distance, remember I just want to divide by 12. I want to figure out how many standard deviations, how many jumps can be squeezed into that amount of space. So if I calculate this out, I'm going to get something like 18 over 12, which I should have gotten as 1.5. So this is 1.5 jumps or standard deviations away. So then I can say that by Chebyshev's theorem, we get 1 minus 1 over 1.5 being squared, and I can figure out what this is going to be equal to. I'll go ahead and use my calculator to help with this. So I'm going to have 1 minus 1 divided by 1.5 squared. And that gets me this value. So to 4 decimal places, that's just a bunch of 5s, maybe round up the last 5 into a 6. So this is going to be roughly equal to 0.5556, or what would be equivalent to saying 55.56%. So I could say at least 55.56% of students score between 88 and 124 points. There we go. Same three-step process we kind of had up above. Hopefully you were able to get to that answer. And of course, if not, there's a whole set of worksheet problems that can help you try to work through your understanding of this topic a bit better. Now the last question we want to look at here in this section is part C, which is very similar to what we just did in part B, but some stuff's going to slightly change. Much like we saw that in the empirical rule, we could have two different types of questions. In the last section with empirical rule, we had some questions that asked for our red percentages, and we had other questions that asked for those black numbers that we had along the number line. Now notice here, we have something very similar. In this first question here in part B, the question was, what percent of students? And so our answer was a particular percent of students. But down here in part C, notice we're being asked for something different. This says two questions. At least what percent of students have a score within 2.2 standard deviations of the mean? That's how I'll answer the first question. But then here, this asks on what interval do these scores occur? Okay, so let's kind of see what we mean by this. We'll start by answering the first question. All right. Again, I know that I'm still dealing with the same scores that we had in on the exam in part A. So I know I have an average of 106 on the test. But notice here, I'm going to say that I'm going to go 2.2 standard deviations away. Okay, so let's see. So here's 3 standard deviations in each direction. I can even mark out the numbers on the number line. Remember that we were going up by 12s. So this is 118, 130, and this would be at 142. If I go down, remember this was 94, 82, and 70. Well, notice if I'm going to go down 2.2 standard deviations, that means I got to go away 2.2 standard deviations. I got to go 1 jump, 2 jump, and then, I don't know, maybe 0.2 jumps is going to land me like right here. That's not maybe a full jump, right? So that's maybe a portion of a jump. If I go down 2.2 jumps, that's maybe going to stop me somewhere around here. And so I kind of have two questions. What is the interval there? What are those green values? That's kind of what my second question asks. But the first question is a simpler one. What percent of students score between these values? Well, notice if I want to ask that or answer that first question, I need to calculate z. But actually, I already have z. So I'll state we have that z is equal to 2.2, right? We already know how many jumps away we need to go to get to our green values. So I can just state that by Chevyshev's theorem, we have 1 minus 1 over 2.2 squared, and I'll go to my calculator to crunch this out. So let's see. 1 minus 1 over 2.2 squared is, okay, 0.7934. So this is approximately 0.7934, or 79.34%. So I have that question kind of already answered, right? I found my percentage. Now, I also need to know my green interval, right? On what interval do these values actually occur? Well, let's see if I can determine that as well. And then I can write all of my answers here in kind of one simple statement. Well, here's actually something that's really great. How much is a standard deviation worth? I mean, didn't we say that here a standard deviation was going up or going down by 12? So if I want to find this value here, I know that I have to go up 12 2 times, but then I have to go this portion, which is up 12, but not a full 12, just a part of a 12, just 0.2 12s. So to find that distance, I would really just do 12 times 0.2. Notice, if I did 12 times 0.2, that would be a distance of an extra 2.4. That's how far I would have to go to get to this number. So I'd have to go from 106 up 12 to 118, up 12 to 130, and then up a little bit extra of a 12, just an extra 0.2 of a 12, and that's an extra 2.4. Notice that that would give me this upper value here at 132.4, since I went 2.4 extra past the 130 mark. Now, another way to have gotten that is to just have said, I could just figure out how much total distance I need to add. We could have said, I need to do 12 2.2 times total. That is, I need to start from the middle, and I need to go up 26.4. I need to start at the center and go up 26.4. Notice if I do that, that lands me at exactly 132.4. So all my values here are working perfectly. Notice that I can do the same thing to figure out how far to go down. So to go down from here, I can say that I needed to go down 12, go down another 12, and then go down not another full 12, just kind of like 0.2, or down another 2.4. Or, again, we could go and say, I need to go 12.2, or sorry, let me clear this out and reword. I need to go 12 2.2 times just below 106. So I could calculate like this. So that means I would have to go down to 79.6. Now, of course, as I write in these values, I'm definitely going to be checking to make sure that they look reasonable. Right? Is this a good spot for 79.6 between these two numbers? Yeah. Is 132 between 130 and 142? Yeah. So these numbers seem reasonable. So notice I can summarize now all of this in one final sentence. We can say at least 79.34% of students score between 79.6 and 132.4 points. Notice again here, I had two portions of this question that I had to answer. The portion on the percentage, but also this portion on the interval. Sometimes we will be asked to go in both directions here. And of course, I think that with some practice, you can get very, very good at this. Please make sure that you go ahead and consult the worksheets associated with these sections, and make sure that you take this stuff, whether it feels easy or hard, and you make sure that you master it. And it's going to require practice, because when it comes to assessments or when it comes to exams, you want to make sure that you are really quick at doing this. You don't want to be in the middle of a test going, how does that work again? You want to just see the problem and go, oh yeah, I know exactly what I should do, and just start cranking out the solution. With some practice, I have no doubt you'll be able to get there. And of course, if you have questions or need help along the way, please, by all means, let me know.